Hey everyone! In today's video, we're going to talk about how to use trigonometry to solve for unknown sides. Before we get into that, let's just review what SOHCAHTOA stands for. Remember, SOHCAHTOA is an acronym that you can use to remember your three trigonometric ratios. First, we have sine is equal to the opposite divided by the hypotenuse. Sine is opposite over hypotenuse. We also have cosine, which is equal to the adjacent divided by the hypotenuse. And finally, we have tangent, which is equal to the opposite divided by the adjacent. Okay, SOHCAHTOA. And remember that we get these three side lengths, the opposite, the hypotenuse, and the adjacent, when we look at our right angle triangle with an unknown or with a highlighted angle here. In this case, our highlighted angle is x. When we are labeling our sides of our triangle, remember, the opposite side is the one that is across from x. The hypotenuse is always the one that is across from the right angle. And then adjacent is the one that is beside the x. I think of it as the one that's left over, okay? So you go opposite is across from x, hypotenuse is across from the right angle, and adjacent is the guy that's left over. And trigonometry can be used for basically two different things. It can help us to solve for unknown sides, like you're going to see in this lesson, and it can help you find unknown angles when you're presented with triangles. Trigonometry is used in a lot of different professions. A lot of people working with triangles, even something as simple as people wanting to frame their basement, or people who are looking to add crown molding around the roof of their, or around the ceiling. Trigonometry is used for a lot of different things. So how do we find our unknown side? Well, our very first step always is to label our sides with respect to our known angle, okay? Then we need to use the side, or we're going to use the side that we know and the side that we don't know to determine which ratio to pick. We're going to pick between sine, cosine, or tan. We have to pick between one of these three things. So based on the information that we have, it'll tell us which ratio to go to. We're then going to write an equation using the information that we know, and finally solve for my unknown using some opposite operations. Okay, it's pretty straightforward, but let's get started with our first example here. So I have a triangle with an angle of 46 degrees down here, and it is a right angle triangle. One side here, my x, that is unknown, and I have this side here, 11, that is known. So the very first thing that we are going to do is start by labeling all of our sides. Remember, opposite is the one that is across from the angle that we have. So the angle we have here is 46, therefore this side, our x side, is our opposite side because it is opposite the 46. We can also label our hypotenuse because our hypotenuse is across from the right angle, so hypotenuse. And finally, we can find our adjacent side as the last one here. And we finally have all three, okay? We have the information for the hypotenuse. So if I want to write out my three ratios here, okay, I'm going to say sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So I need to say, okay, I have my hypotenuse, and therefore I need to pick a ratio that has a hypotenuse in it. There's a hypotenuse in sine, and there's a hypotenuse in cosine. There is not a hypotenuse in tan, so I'm going to rule out tan. And then I need to say, okay, Well, I need to find x. That's what the question is asking. I need to find x, and x is my opposite side. So I need to also find a ratio that has the opposite in it. Sine is going to fit the bill because sine has opposite and it has hypotenuse. I'm going to cross off my cosine here. Sine is the one that we are interested in. And here's how we are going to write our equation. We're going to start with sine, and then you have to write the angle that you were given. So in this case, sine of 46 degrees. So I just plop that angle right beside my sine. Equals, and then I have a fraction here, and then I say opposite over my hypotenuse. Well, opposite is x. I don't know what it is, so x is going to go on top. Hypotenuse is 11. Hypotenuse is going to go underneath, so a sine 46 equals x divided by 11. Now, what does sine of 46 look like? What does that even mean? Well, we have to type into our calculator here. You want to make sure your calculator is on degree mode, otherwise you will be given the wrong answer. I'm going to type sine of 46 equals, and you're going to get a very long decimal here. Well, our question says round to 1 decimal place, so that's what I'm going to do. I'm just going to take the first decimal here. That is just a 0.7, so sine 46, that is equal to 0.7. 0.7 is x divided by 11. Now we can use our opposite operations. We're trying to find x. This is x divided by 11, so we need to multiply this by 11 in order to get x on its own. If we multiply one side by 11, we have to multiply the other side by 11. So let's do that. Let's multiply both sides by 11. 0.7 times 11 is equal to 7.7. We already said these 11s would cancel out, and so my x is 7.7. That is my final side. And so we just managed to figure out, using a length and using an angle, what another length was. Okay? First thing, we picked our ratio, then we wrote our equation, and then we solved for x. Very straightforward. Let's do 2 more examples. Here I have another triangle. I have 27 degrees as my angle. I have an unknown side x, and I have a known side of 10. Okay, what am I going to do here? Remember, first things first is we have to label our triangle. So I'm going to go ahead and label it. X is my opposite side because it is opposite from 27. I have my hypotenuse here because it is opposite my right angle. And my last side, my side with the value of 10, is my adjacent side. Okay, because it is the one that is beside my angle. Now that I've labeled them, I need to pick the correct ratio. So I'm going to write them out. I'm going to write sine is equal to O over H, cosine is A over H, and tan is equal to O over A. Well, first things first, we need to pick one that has the information that we are given, and we were given that the adjacent side is equal to 10. So I have to pick a ratio that has an A in it. There's an A in cosine, and there's an A in tan. There is no A in our sine ratio, so that is being thrown out. I also need to pick one that has my opposite side in it because I need to find x. So I need to pick a side that has an O in it. And in that case, that leads us to our tan ratio. We can throw out cosine. Tan is equal to opposite divided by adjacent. We need to know the opposite side, and we have the adjacent side, so we are good to go there. Let's write our equation. Remember, tan, and then we write our degree, we write our angle, so tan of 27 is equal to opposite divided by adjacent. Opposite is x, adjacent is 10. So tan of 27 is x divided by 10. Okay? Now I'm taking my calculator and I'm going to go tan of 27 is equal to this long decimal. Remember, we're only rounding to one decimal place, so I'm going to round this to 0.5 is equal to x divided by 10. Now in order to get x on its own, we have to multiply both sides by 10. Do that opposite operation. 0.5 times 10, let's put that in our calculator. 0.5 times 10 is equal to 5. These 10s cancel out, leaving me with x. So x is equal to 5. And let's do one last example here with this triangle. I have one side is 7, one side is x, and the angle in between is 39 degrees. Again, let's start by labeling our triangle. This is probably the most important step when you're solving these types of problems. We're going to find our opposite. That's the one that is opposite the angle given. We find our hypotenuse. The hypotenuse is across from the right angle. And finally, we have our adjacent. That's the side that's left over. It's the one right beside the angle. Okay, I'm going to write out my three ratios again. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And finally, tangent is equal to opposite over adjacent. Okay. Remember, we need to pick a ratio that uses the information we were provided. And we were provided with our hypotenuse length. So I need to pick a ratio that has a hypotenuse in it. Okay. I also need to pick a ratio that has an adjacent in it. An adjacent in it. Because there's no hypotenuse in tan, I can cross out tan. And I'm looking for a ratio that has adjacent, and our answer is going to be cosine. Cosine is our answer because it has adjacent and hypotenuse. I throw out the sign. Cosine is adjacent over hypotenuse because I need to find my adjacent and I have my hypotenuse. So let's go ahead and let's write our equation out here. So I'm going to write cosine of my angle. Cosine of my angle is equal to adjacent, which is x, divided by hypotenuse, which is 7. So cosine of 39 is x over 7. Okay. First things first, I'm going to type cosine of 39 into my calculator. Cos 39 is equal to 0. A lot of stuff, and so let's round to one decimal place. I need to round up to be 0.8, so it's going to be 0.8 is equal to x over 7. In order to get x on its own, I have to use my opposite operations. So I multiply everything by 7. I'm going to do 0.8 times 7. That gives me 5.6. And these 7s cancel out. For my final answer of x is 5.6. Okay? So when you're solving these types of problems, when you have an unknown side, remember we need to start by labeling our sides given the angle that we have. I need to pick which ratio makes the most sense given the side that I know and the side that I don't know. I need to write an equation, and then I need to solve for the unknown using my opposite operations. Okay? You don't need to write out all of these steps every time. You don't need to write out where you're choosing between them. You can jump straight to the equation if you want, but until you get comfortable picking which one, it's best to write it out and actually formalize your thought process that way. Okay? Great work, everyone.